Okay, so our next topic will be hydrostatic load on ship structures. So hydrostatic load on ship structures in marine engineering. Introduction. So hydrostatic load refers to the pressure exerted by the water on the submerged part of a ship's hull or other structure. So this pressure increases with depth due to the weight of the water above. So hydrostatic pressure is a critical factor in the design and operation of ships, as it determines the forces acting on the vessel's structure. So a hydrostatic load on ship structure must be carefully calculated to ensure the ship can withstand the stresses during operation, whether it is floating, docking, or subjected to external forces such as waves. So here is the formula for our hydrostatic load. Pressure is equals to Philippine General Hospital, PGH. So pressure is hydrostatic pressure in Pascal. Density of the fluid in kilogram per cubic meter, gravity by 9.81 meter per second squared, and height, which is the depth below the surface of the water. So here, the hydrostatic load distribution and ship structure. So on ship this is distributed unevenly along the hull because the pressure increases with depth. So the load distribution varies depending on the ship's draft, the shape of the hull, and the location of the structures. So there is pressure distribution, hydrostatic force on vertical surface, and hydrostatic force on curved surface. So there are different calculations that can be used. But on our ship, so we will just have to do this on the basic, just the basic. Okay, calculation of hydrostatic load on ship hull has several key factors, like the shape of the hull, draft of the ship, surface area of the submerged portion. Okay. So here is an example. So we have a given data. Depth of water line is 10 meter. Density of water is 1,000 kilograms. So this is seawater. So we will correct this one. This is 1025 kilogram per cubic meter. Gravitational acceleration is 9.81 meter per second squared. Vertical length of the ship submerged in water is around 30 meters. So this is the given. So using that given, you will have to multiply Pmax is equal to PGH, which is 1025 times 9.81 times 10 cubic meter, which is the depth of the water to the bottom of the hull. Okay, so that is this will be rechecked. This will not, because we are using 1025, so the answer will be change. Okay, and then using that formula, you will get the 1/2 times 98,100 Pascal, or the value here is changed already, times 30 meter, which is the vertical length of ship's side submerged in water. So times 30 meter, you will get a Newton, which is the hydrostatic force on the vertical surface. So we have hydrostatic force on the horizontal or the bottom, and the vertical. Okay, so application of hydrostatic load on ship structures in marine engineering. We have the structure, depending on your, it will be used in your structural design. It will also be used on the stress and strain analysis of your ship. You have the stability assessment of your ship, ballast management for stability of your ship, and hull maintenance. So this hydrostatic load can be used to calculate these different types of uses on our on our ship structure. Okay, that's it. So I hope you learned something today. Our next video will be pump heads, and I'll see you on our next video. Bye.